What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. So in this video we will be looking at part 6 of our MatPlotLib tutorial series. You guys know this is a data visualization with Python tutorial series. So in this video, essentially what we will be doing is we will look at more, plots and features that Matplotlib offers us. We will kickstart this session by learning about what I mentioned in the previous video. It is called a back-to-back bar chart. So a back-to-back bar chart, it is nothing difficult. Essentially, you can think of it as a horizontal bar chart on which you can have two bars, and essentially these bars, they kind of stem from the center point and they both extend. One graph can extend to the left and the other can extend to the right. So it is nothing difficult. Matplotlib does most of the hard work for us. All we need to know is the method to use and how to use it. So let's actually do this. Go ahead, import your packages, import numpy as np, import matplotlib.pyplot as plt. So what I'd like to do now, okay, suppose now we have this data that we are working with. It is the population of men and women. So we have these two, data sets. One is having the values that represent the population of men, and the other is having values that represent the population of women. So I will set up a few arrays here. So just two arrays, women population. We can make these numpy arrays since we have imported numpy. Just to throw in some values, suppose we have 5, 30, and maybe 45, followed by a 22. Just 4 values. And here we have a second array. Men population is equals to a numpy array. And within this, suppose we have 5, 25, 50, and 20. Those are the arrays we are working with. Now, obviously, we need to have, x values. And in this case, since we are plotting a horizontal bar graph, the x values is basically the y values. Okay, so remember, we spoke about how, the difference between a standard, maybe we can just say a stacked bar chart, the one that has the bars spanning vertically, and the difference between the one where the bars are horizontally is not much. Essentially the same canvas is just rotated, to give the bars a different representation. So x is equals to numpy.arange. Suppose I just like 4 values here because I have 4 values that will be plotted. So what we will do now is plt.barh, and within this plt.barh we will pass x. This is the y values themselves. As you can see, the name of the parameter, the width for this. Suppose now, let me give you a bit of insight. So suppose now, it's as I mentioned, right? We have two data sets. Suppose we'd like to display the male population on the left side of this bar chart and the women population on the right side of this bar chart. Now, just to give you a bit of insight before we even go ahead and plot this, it is simple. You see, the idea to have two bar charts that can be back to back is very simple, and it uses a simple, I would say, logic, okay, or a trick. And that trick is that the length or the height of one bar can be negative. So essentially, going to the right will have positive values, and going to the left kind of denotes a negative values. So ideally, both of these bar charts would stem from a common sort of axis, okay, and they will both go in a left and a right direction. If that makes sense to you, that's good. If it doesn't, don't stress. When you look at the code and the visualization itself, you will realize how simple it is. So for the first bar chart we'd like to plot, let's go ahead and let's plot the women population. Now think about it. I just mentioned to you, on the right side we want to show female or woman population. Right side is positive. So the width of the bars need to be positive. In the array itself, these values are positive, so we don't need to, mess around with these in any way. So we'll just pass X woman population. Suppose we'd like to, to set a color to be equals to R. I will just copy this. Now what we are doing, X remains the same, and now we shall change this to men population. Now think about it. If I leave men population as is, right, what's going to happen is that it's going to be plotted over those bars that were depicting or denoting the women population. Now essentially, what I need to do is I need to place a negative value here, because instead of taking up space on the right side of the bar chart, okay, of the canvas, the bars depicting the men population is actually going to span negative. So that this means the left side of that axis, or of that Cartesian plane, of that canvas. Okay, and this is what gives us the ability to have those two bars. In our case, the bars representing male and female population, on a single set of axes. So color can be set equals to B. Now we shall do a plt.show, control enter, and as you guys can see, this is what we have. So it is super interesting, it is super cool. Okay, so that's that. The next thing I'd like to demonstrate for you guys is a very famous kind of plot. It is called a pie chart. Pie charts are really helpful, especially when you are dealing with several values that basically compare quantities or relevance of stuff. So this is when you'd like to use a pie chart. So what we will do is I will import again. I am importing, so you guys have a full script uh, at a later stage. After we reach the end of this MatPlotLib tutorial, you guys will have a very, very neat, well coded, neat, documented MatPlotLib script that you can reference in the future. So import matplotlib.pyplot as plt. Now what we will do, plotting a pie chart is probably one of the easiest things you can do. This is us doing it in the raw form, the base level form. We are not adding any styling to any of the graphs that we are working with so far. This is just me showing you all of MatPlotlib's possibilities. The styling portions and so on, that will come in a later stage as soon as we have covered the major types of visualizations that you can encounter and use in the real world. So what you want to do for the pie chart, guys, you want to use plt.py. Essentially, we have a pie method here. This pie method is available to us from the pyplot sub package, and the most important parameter I'd like to discuss for you guys is x. That's the most important one for now. It's the compulsory one. X represents an array or a sequence, okay? And essentially, each of the values in the array or the sequence will be given a slice of that pie chart. Okay, matplotlib does the computations for us, so we don't have to stress about that. Now plt.py, we have it easy here. We have data already that we have created, and after this plt.show. Now I go ahead, I run this, and as you guys can see, we get this neat circular visualization that kind of depicts our data in slices. This is what makes it a pie chart. Now if you look at this, you will agree with me, this is bland. Okay, in the real world you'll hardly ever encounter something in a basic form like this. There's always annotations, labels, and so on. and this is what we will cover, in the near future. So that is interesting. Now, what I'd like to do is that, you see, we have about two more plots that we need to cover, and they are nothing difficult at all. So yeah, two or three. So I will just try to cover it in this video here, right? Since this is 10 minutes long only, and we can do it in a relatively short space of time. So we might as well round up all the, plottings and visualizations that MatPlotLib has to offer in this video here. So this is fun either way. So let's go ahead and do this. So the next interesting thing is what they call a histogram. You guys know a histogram is a close cousin of a bar graph or bar chart, right? Histograms are basically graphical representations of the probability distribution. Okay, so as I mentioned, logically speaking, you can just think of a histogram as a very special kind of bar chart. Now, we have the ability to plot histograms in using matplotlib. uh, Matplotlib has a dedicated function or method for them, so let me just comment this: plotting a histogram with matplotlib. This is also an easy task to do or to achieve. So import numpy as np, import matplotlib.py plot as plt. And you see, guys, since we are plotting a histogram, right? You guys know we've spoken about this, how a bar graph has spaces between each bar. And the thing with a histogram is that there are no spaces between the bars. Okay, so it's just kind of one connected graph. Now the thing is, matplotlib has a built-in method for bar graphs, and there is a separate one for histogram. So what we will utilize is plt.hist. Okay, this method is what will enable us to plot a histogram. So we have imported the respective packages that we need. For now, what we will do is just create some dummy data. So for this, I can do numpy.random.randn, and within this, suppose I'd like 1000 values. So what I'd like to do now is I would like to plot a histogram for this data. So you guys know, right? If you are familiar with histograms in general, you'd know that they have what we call bins, bins. And really, guys, the bin is just the name given to each of those bars. So together they form bins, and matplotlib gives us the ability. So as you guys can see, the most important parameter for us to pass is x. Okay, for bins there's nothing we have to do. So if we run this as plt hist x plt show, control enter, I just want you guys to have a look at the output we receive. So this is what we receive here. Now I have the ability to tamper with this parameter called bins, and I can set this to a value that I would like. So suppose I would like to have 20 bins. Now pay careful attention. In fact, what has happened is that there are 20 bars here. If you count these bars or these bins, there will be 20 of them. So I have the ability to set this to a value of 10. And if we count 1 2 3 4 5 6 7 8 9, and there's a little one at the end as well, which is 10. So that's what the bins parameter actually does. There is no limit to the number of bins you can create for your data. You can go ahead and actually play around with that. Now essentially what these bins are doing is they are attempting to kind of group those close values in the same bin, because think about it, x contains several values, And what our bins is trying to do is actually trying to group and find those values that are closest together, and it's grouping them into these bins. And what's changing is the count of the numbers that lie within these bins. Essentially, on the y-axis here, we see large values, and these large values is the sum of numbers that lie inside a specific bin. So I hope this is making sense to you. And once you understand that, really that's all you need to understand about the basics of plotting histograms using MatPlotLib. So the next plot I'd like to show you guys is what is called a box plot. This is an interesting one. So essentially, a box plot will allow us to compare distributions of values. Okay, and how it does this is it conveniently shows us, statistics such as medians, quartiles, maximum, minimums, and so on. So let me actually demonstrate this for you. What I'd like to do is import numpy as np, import matplotlib.pyplot as plt. I will set up some dummy data, numpy.random rand. Let's use the rand method again. This time, suppose we'd like 100 values. So what I can do now is plt.boxplot. Again, all we need to pass here is a single array, a sequence. In our case, we have it as data containing those 100 values for us. plt.show, and I would like you guys to view what the output of this kind of visualization is. And as you see, guys, this is a box plot. What we have here is a box plot, and it is commonly drawn, in math. When we work with our functions and parabolas and hyperbolas and so on in math, we tend to also cover the concept of box plots. So super interesting, right? What I'd also like to mention to you, just in case you are not familiar with exactly what this little diagram is. So essentially, right, what I'd like to tell you is that you see, guys, this value in the middle here, the orange one on my screen, I'm not sure if it differs across Python IDEs or so on, but the orange one, the line in the middle, that's the median of the values that we are working with. Okay, the median. Then if you are wondering, what does the entire graph, it's the entire box itself, what does this box itself tell us? What information is conveyed from this box we see on the screen? So essentially, the box itself includes 50% of the data, okay, from the lower quartile to the upper quartile. And this is why we see that the box will be centered on the median of the data. Okay, that's an observation you will make. Now, I should also mention to you, right, what I'd like to tell you is that the lower whisker that we see, oftentimes you may know this as the a whisker plot. I'm not too sure about the name itself, but box plot is also known by another name. And the reason why it's known by another name is because of these lines that extend out of the box itself. So essentially what I'd like to just tell you, right, is that we have statistics that are shown to us from this plot. The orange line is the median. The box itself contains 50% of the data from the upper and the lower quartiles, and this is why we see that the box will be centered. But in our case, we are using randomly generated values, so each time I run the script, right, you will notice that there will be a change. Oftentimes or sometimes it will be centered, sometimes it won't be centered. So as you see here, this is one way it's centered. It's using 50% of the data from lower quartile and upper quartile. It will be centered. We have a minimum, we have a maximum value, and we also have outliers that are depicted or shown by this plot. So it is very interesting information. I should mention to you, initially when I was saying that the plot is centered, uh, it was actually looking centered, but it was not. So that's why I ran the script multiple times to get one in which it is centered. So I won't dwell too much on that. The box and whisker plot is for you to, look up more on in your spare time. We will definitely look at styling and more, I would say, information pertaining to these at a later stage. But for now, this is just me showing you what MatPlotLib can do. Now, you may ask yourself, right? If I want to, display more than one box and whisker plot or box plot on a single canvas, how will I do this? Now, the answer to this is quite easy, right? Essentially, you'll notice that up here in the first box plot that we drew, we had a 1D array. Now the thing is, each array or sub array in your major array, your main array, it will actually be given its own space or own plot in the box plot diagram. Okay, so what I'm saying is that if I had a 2D array here, I would have two box plots showing up, two on the same canvas. Okay, if I had a 4D or 5D array here, up here, then I'd have, one box plot for each dimension. So I'd have, 4 or 5 box plots showing on the same canvas. So I will demonstrate for you. Let me proceed to import numpy as np. Import matplotlib.pyplot as plt. Let's do data is equals to numpy.random.randn. This time the shape I'd like is 100 by 5. So you guys can check again. Data.shape 100 by 5. That's good. Now it is time to plot multiple box plots on the same canvas. So what we can do is, it is easy, guys. The array itself was the only thing that had to be tweaked, the data that's going to be fed into the box plot diagram. So again, I pass data plt.show, and what you guys will notice is that a very fancy diagram is drawn in which 5 box plots are, residing on a single canvas. So there you have it. Now, if I'm not mistaken, there is one last thing I'd like to show you for this video, and this is the last visualization we will look at. After this point, in the next video and so on, we will explore several more features that MatPlotLib has to offer us. We'll look at some styling options and features and so on. So another cell to be created, import numpy as np. So I should mention, what we are plotting now is called triangulations. Okay, triangulations is what arises when we deal with spatial locations. In other words, when you are dealing with spatial data is basically your geographic data, right? You will tend to use triangulations, because apart from showing the distances between 2 points and so on, triangulation plots are also very convenient when it comes to working and representing maps and so on. Okay, so it is super interesting stuff. GPS and so on, they are based, and the only reason why they can pinpoint your location is because of a technique that is called triangulation. So import numpy as np, we did that. Import matplotlib.pyplot as plt. Another importation here, guys. Import matplotlib.tri as tri. So the triangulation portions are coming from matplotlib.tri. That's the sub package. Now what I'd like to do is create some dummy data, random.randn. Within this, suppose we have a 100 by 2 array, and now what I'll do is triangles is equals to tri dot triangulation, and within the triangulation we need to pass x and y. Okay, unstructured, basically you don't have to be concerned about the documentation. To put it for you simply, all you need to do is pass x values and y values, okay, and leave the rest of the parameters the same. We will look at that maybe at a later stage. For now, all you need to know is the x and y here is the standard x and y, okay, the x and y that you'd find like on your line graph, on your scatter plot and so on. So since we have created a 2D array for data, what we can do is just slice. So all rows of column 0 and y will set equals to all rows of column 1. Now what I'd like to do, plt dot, as you see it here, try plot. So essentially the triangulation method that we utilize from the try package or sub package is what actually calculates the values of the triangulation for us, okay. And when we do the try plot itself, this is when you will see the entire triangulation plotted. I want you guys to think of a triangulation plot or triangulation as a very fancy line graph, okay, because you'll notice that the lines are all joined and they tend to form triangles. So plt.tryplot triangles, and within this plt.show, control enter, and this is what you guys will see. This is our triangulation. In the real world, this statistic is very powerful and it is often used and encountered when working with maps and spatial data. So the numbers are being randomly generated. You guys can keep running this to view the visualization that's actually generated. Okay, so with this, guys, this is all I wanted to cover in this specific section of the tutorial series. What we did is that we covered, I would say, a good or sufficient amount of visualizations and representations that MatPlotLib offers us, okay. And in the future video, in the next portion of the videos for the MatPlotLib series, what we will do is we will work on customizations and styling and colors and so on. So with that, guys, thanks for watching. Thanks for staying till the end of the video. Do be sure to leave a like for the video if you find these tutorials interesting, and subscribe to my channel for sure. Thanks for your time, guys. Good luck with your work, and I'll see you in the next YouTube video.